Alrighty, page 55 when we're done. So we're going to look at the relationship between the sides and the angles in a triangle, because even though if all we're given are the sides of a triangle, it does tell us some things about the angles and vice versa. Okay, so this first theorem says if two sides of a triangle, are not congruent, okay, that means we're talking about triangles that, are not isosceles, not equilateral. If two sides of a triangle are not congruent, then the larger angle, okay, so here it says that, the larger angle is opposite the longer side. So it's telling us over here that the length of AB is bigger than the length of BC, right? So then we look at the angles across from them, and because mine's in color, it looks a little different than yours, which is just in black and white or black and pink, whatever. So on yours, it kind of looks like they've marked that the angles are congruent, and they're not. So just put an extra little mark right here just so we know what's going on and that they're not. We're not saying that they're congruent. Because if the sides aren't congruent, the angles aren't congruent, right? Because if those two sides were congruent, that makes it an isosceles triangle, which would mean then these angles are congruent. But that's not what's happening. Instead, the triangle, this AB is actually longer than BC, which means that, just like it says right here, the larger angle is across from the longer side. So across from AB, which is the larger one, is the larger angle. Okay? So my conclusion then is that the measure of angle C is greater than the measure of angle A. So just think about, let's say that this was an isosceles triangle, and these two are congruent, right? And then I pull B up so that I stretch this side to make it longer. Well, as I stretch this side to make it longer, isn't it going to make this angle open up to be bigger? Does that make sense? So it kind of makes sense that the longer side's across from the bigger angle and so forth. Okay, we all good with that? Is across from the bigger angle. Always. Always. So think about this. In a right triangle, what can you tell me about the hypotenuse? It's across from the 90-degree angle, and that's how you identify it. And then also, what do we know about it? It is always the what? Longest side, okay? It's always the longest side because it's across from 90. That's why it's the longest side, not just because it's the biggest number. The way you identify the hypotenuse is that it is across from the right angle, because you don't always have the numbers to know it's the longest side. But it is always the longest side. You just have to be able to, you can't identify it that way necessarily. But so the hypotenuse is always across from 90. In a right triangle, is the 90-degree angle always the biggest angle? Yes, and that's why the hypotenuse is always the longest side. Does that make sense? So you've actually been applying that for this thing for a long time. You just didn't realize it because it was never really said to you that way. But that's true in any triangle, not necessarily just a right triangle. What the heck are you doing? Yeah, thank you. All right, so now this one says, if two angles of a triangle are not congruent, then the longer side is opposite the larger angle. So it works both ways. So again here, they're kind of marked that they're congruent and they're not, so we're going to put an extra little mark right there. And then, so this says the measure of angle Z, oh dang it, I left off the M again. That should be is greater than the measure of angle Y, the little M got left off there. Because these are inequalities, it's still not congruent, so I have to talk about the measures. So the measure of angle Z is larger than the measure of angle Y, which means that across from XY, if this is the larger angle, that's the longer side. So the length of XY is greater than the length of XZ. Okay, everybody okay with that? We good? All right, so bigger side is across from biggest angle, smallest side across from smallest angle, and vice versa. Very simple. So when we look at example 1, it says write the angles in order from smallest to largest. Okay, so a couple of things. These are really, really easy questions. We should not be missing them. So make sure you read them. We're writing angles, okay? So don't write down sides because that makes no sense, right? I'm writing down angles in order, and then also make sure you look at the order. Smallest to largest, right? How do I figure out which is the smallest angle? What do I look for? The short, because I don't have angle measures. It's not like I can tell you the angle measures and then figure out which is the smallest number, right? It's across from the shortest side. This is the shortest side. So the angle across from that is angle H. So my smallest angle is angle H. And then my next smallest angle is across from that, which is J. And then the next one is G. Okay, easy enough? Also notice, did I write the measure of angle H, the measure of angle J? No, because it doesn't say write the measures of the angles. It says write the angles. That's how you name an angle. We good? All right. Now on B, we are writing the sides of an angle, or some sides of an angle, that makes no sense. We're writing the sides in order from shortest to longest. So me naming angles over here makes no sense, right? So I'm looking for the shortest side. Can I determine that at this point? No, because you don't know the third angle. How do you know that angle L is the smallest when you don't even know all three angles? Does that make sense? I have to know all three because maybe that's not the shortest. I don't know. Okay, but I can find it. So I'm going to call this X. So I know then that X plus 54 plus 39 equals 180, right? So what's 54 plus 39? 93 equals 180, which means that X equals what? 87 degrees. Okay, so this right here is 87 degrees. All right, so 39 is the smallest, but not just because of the way it looks. You got to actually find them because that may not always be the case for you. All right, so now I'm looking for shortest to longest, shortest sides across from the smallest angle. So my shortest side is KM. Do I need a line segment above it? I mean, I didn't have them here. Do I need it here? Yes, because if I'm going to write with a side, this says the length of line segment KM. Is that the side of the triangle? No, the side is a line segment KM, or MK, doesn't matter. And then the next one has to be across from the 54, so that would be LM. And then the last one would be KL. Okay, everybody okay with that? Any questions at all? All right, so then the next one says, write the sides of triangle ABC in order from shortest to longest if this is true. So the first thing I need to do is draw myself a triangle. So I'm going to draw a triangle. I have no idea what kind of triangle it's supposed to be. I'm just going to draw it where I can actually label stuff in there. We'll name this A, B, C. So measure of angle A is x squared minus 25x. Measure of angle B is x squared minus 10x. Measure of angle C is 5x plus 28. Okay. Now, am I able to determine just based on that which one's the biggest and which one's the smallest? No, because it totally depends on what x is. So I got to find x, right? I'm looking for angles of a triangle. So could I just like add two of them together and subtract from 180? No. You see why I'm not letting you do that every single time, right? All three angles of a triangle, what do I do with them? Add them up, set them equal to 180, right? So I'm going to start with, I'll start with A. X squared minus 25, oops, if I write the right numbers. 25x plus angle B, which is x squared minus 10x plus angle C, which is 5x plus 28. All that together equals 180. First step, zero work. You just plug it in. I didn't combine anything when I wrote it down. Okay, that shows me where everything came from. Now, if I skip steps along the way, not that big of a deal. But I'd be careful when you have a ton of stuff, like skipping steps. Make sure you don't miss anything in here. So I'm going to combine my like terms, which means I'm going to take this is the x squared and this is x squared. So that gives me what? 2x squared. And then I've got negative 25x and a negative 10x. That gives me what? Negative 35. And then a positive 5x. That leaves me with a what? Negative 30x. And then I just have one whole number here, and that is 28. And that's equal to 180. Okay. So I want to know, what kind of equation do I have, Kevin? What kind of equation is this? What do we call this? Quadratic. Very good. right? It's quadratic. First step is identifying that it's a quadratic. So I need to solve this quadratic, right? There are different ways to solve a quadratic, but probably all the ways you know now, you have to do one thing first. You have to set it equal to 0. Step 1 is identifying it. Step 2 is setting it equal to 0. I saw a lot of people yesterday trying to do stuff at this stage, which had to do with factoring, which is 100% wrong. Okay, there are ways to solve quadratics where you don't set it equal to 0, but I don't know that you've actually learned those. So as far as you're concerned right now, I'm pretty sure every way you know is setting it equal to 0, which means that, and you also want to keep your x squared term positive if at all possible. It's already positive, so I don't want to move it over there and make it negative. So it's going to give me 2x squared minus 30x, and then when I subtract 180 over here, negative 152, okay, and that's equal to 0. So now I'm going to factor it. I am not going to start by multiplying 2 times a negative 152. After you have identified that it's a quadratic and you have set it equal to 0, step 3, all 3 of these first 3 steps are like the most important steps in the whole thing. Then you factor out a GCF. Now listen carefully to my words. You factor it out. We do not divide everything and make it disappear. Okay? You will end up with the same answer in the end. But when you get into Algebra 2 and you start doing more with factoring and stuff again, and you start just dividing stuff out and making it disappear, you're going to be very confused why you're getting stuff wrong all the time. So it's very important, even when what you do may not affect your final answer, that you're keeping your steps correct like they're supposed to be. So is there a GCF here? It is 2. So I'm going to factor it out. See, he's just being factored out. He's not being divided away. So then I do divide each term by 2, but that doesn't mean that the 2 disappears. So that leaves me with x squared, then what? Minus 15x minus 76 equals 0. Now, if I had dropped him off, then if I finish factoring correctly, it's not going to affect the answer in the end. However, he needs to stay there. He's just along for the rest of the ride. Okay? So now I want to factor. And when I'm factoring this, isn't this right here easier to factor than this one? Like, you have less possibilities with the numbers. Your numbers are smaller. So factoring out the GCF, and there's some of you that didn't factor out the GCF yesterday, still factored beautifully, got the right answers in the end. And then I came around, and for people that were working, I was trying to hit everybody and say, look, your answers are right. I'm not going to make you change anything yet right now. But what I want you to understand is if the instructions said factor completely and solve, you weren't factored completely because you hadn't actually factored out the GCF at the beginning. Plus, that does make things easier. It is possible to factor this without it, but this will definitely make your life easier. Okay. So, and also don't lose your equals 0. This is an equation. All this equals 0 every time. That's the whole point of what you're doing. Okay, so now we are looking for two numbers that multiply to give you a negative 76 and combine to give you a negative 15, right? Negative 76 is probably not a number that you have multiples in your head all the time, right? So you start making yourself a list, right? And then so factors could be 1 and 76, right? Since this is negative, are the signs here going to be the same or opposite? Opposite. So if I subtract in either direction, am I going to get 15? No. Okay, so then I go to the next one. All right, so 2. So 2 times what gives me 76? 38. Okay. And then I can try 3. Are 2 and 38 going to work? No. So then I try 3. Is 76 divisible by 3? No. So then is it divisible by 4? Yes. And you know how you can tell that real easily without having to actually try and divide? You've already divided a 2 out. If this is also divisible by 2, that means the whole thing is divisible by 4. Does that make sense? Okay, so this gives me 4 and what? 19. Is there a way to subtract those to make it work? Yes. Okay, which one would be negative? The 19. Now, although there's a lot of you, I think all of you learn to factor by grouping, and there's nothing wrong with that. But when your A is 1, you factoring by grouping is actually way more work than is necessary. If A is not 1, like if it had to be 2, because sometimes you can't factor that away, then you definitely want to do that by grouping, by splitting that up. But you already have what you need and what you should end up with. And some of y'all are getting stuck at the factoring out the binomial part of the grouping of this. Once you have your 2 things, this is where we are here. We get 2 because he's still along for the ride. And I'm getting 2 binomials. Okay, I can only skip the grouping steps if A is 1, right? A is 1, so I'm good. So I know this has to be X, this has to be X. You have already decided for the signs of those numbers, and so it's a positive 4 and a negative 19. And it's factored. Okay, you don't have to go through all the terrible steps of grouping. You can, and some of you are, and you're doing it correctly, and that's fine. And if you feel better with that, that's fine. I'm not saying you have to change. But some of you are getting stuck in that, and then I see commas and things, and then people are trying to convince me that, oh, that's because we were doing it differently. No, nobody taught you that. I promise nobody ever taught you that, okay? No. Yes, you were using it for different purposes, but not really. You think they're different purposes, and it really wasn't. But no, there's no commas in here yet. No, no. All right, so now I still have to solve it. This is factored. This is the fully factored form. I've got my equal to 0. I've got my 2 there. That is fully factored. Now I take them, each term that has an X in it, like the 2 doesn't really matter anymore. He matters, but he doesn't affect my answer. And I take each one of these and I set them equal to 0. So I've got X plus 4 equals 0, and I've got X minus 19 equals 0. So that means X equals negative 4 and X equals 19, right? Are both answers always going to work? No. Could they both work? Yes, and you could have 2 different sets of answers. That will happen sometimes. Most of the time, if you're going to throw one away, which one do you usually throw away? The negative. Okay, so let's go ahead and try the 19. Let me just show you this. If we start with the measure of angle A, right? So the measure of angle A, you can't see it up there anymore. So it's what? X squared minus 25. All right, so I'm just going to write this down. It's X squared minus 25 times X, which is 19. So before we do any math, you should know what 19 squared is, first of all. You should know your perfect squares up to 25. There will be a time in this school year when I start quizzing you on those. You have like 30 seconds to write them all down. You've got to know them, just like you got to know your multiplication tables. If you don't, you might as well start now because you're going to start having timed quizzes on that too. Because there's always a point in the year when I just get frustrated. One of the reasons some of y'all have trouble factoring is because you don't know your multiplication facts. Okay, so you got to know it. It will help you greatly with a lot of things. Anyway, so yes. Mm-hmm. Good. And if your mom isn't Mrs. Ludicky, how else should you have already known that? Yeah, on the summer assignment, it said it on there too, right? So that's another way to know it. So it's not like you didn't know already. But it's not just like, again, that's not a me thing. That's the only way you're going to survive an AP easily is if you actually know that and you can do things quickly and easily, I promise. All right, so let's just think. Now, we can think harder, not smarter. Or, no, think smarter, not harder. Said that wrong. Before we even do this, whether I know what that is or not, 19 squared minus 25 times 19. I don't want the actual value of that. Just tell me something about that answer. It's going to be what? It's got to be greater than 180? I don't know about all that. The final answer, not just 19 squared. It's going to be negative, right? Isn't this 19 times 19? So I have 19 19s, and I'm going to subtract 25 19s. Do I have 25 of them I could even take away? No. So that means this answer, whatever it is going to be negative, right? Does a negative angle make sense in this situation? No. So if you can understand what's going on, that's why I'm telling you, if you take a minute to try and actually analyze what's happening instead of just randomly doing work with numbers all over the place, that you actually can save yourself some stuff. 19 isn't going to work. 19 doesn't work, right? So hopefully negative 4 works, or maybe we did something wrong along the way. So let's go up here and plug those in. Let's go up here where I can see it a little bit better. We're going to try the negative 4. So if I find the measure of angle A, okay, that is going to be negative 4 squared minus 25 times negative 4. Right? So what's negative 4 squared? 16. What's negative 25 times negative 4? 100. So this is 116. That's good. Measure of angle B is equal to negative 4 squared minus 10 times negative 4. So this is 16, then what? Plus 40. So this is, what is that? 56. And then the measure of angle C is equal to 5 times a negative 4 plus 28. Okay, so that gives me a negative 20. Uh-oh. Plus 28, what does that give me? 8. If I add those 3 numbers up, what should they give me? 180. Okay, so you can check yourself that way if you need to. But there are your three angle measures, right? So angle A is 116, B is 56, and C is 8 degrees. Am I done? No, because it actually says write the sides in order from shortest or from longest to shortest. Okay, I haven't even done nothing with sides yet because I've been doing angles. They don't give me anything about the sides, but what I need to do here is from longest to shortest. I need the angle measures to be able to tell me that. I can't tell you what the side lengths are at this point, but I can tell you which one's the longest. So the longest one is which one? CB. Okay, so line segment CB, and then which is the next longest one? AC, and then AB. Okay. There's your, all of that is part of your answer. Like if that's all you had, where the heck did you get that? You've got to show all the other stuff that you have there. Okay, we good? Think about what I said about factoring. You factor out the GCF. It's the opposite of distribution, so we're not dividing it out and making it disappear. Okay, any questions? All right, next page. Alrighty. Alrighty, so a triangle is formed by 3 segments, but just because I give you 3 segments doesn't mean you can actually form a triangle. And when we were talking about types of triangles, I gave you a triangle, and I told you at that point, well, this one doesn't actually make a triangle, but I know you don't know that at this point, but I just kind of wanted to put that out there in case you looked back at it and realized that it doesn't work. So these 3 sides that I have right here in my hand, these make a triangle, right? I can make that triangle right there. I can even make the triangle more like this, right? But the longer I stretch out the bottom one, at some point, it's not going to actually make a triangle. Okay, I can't stretch it out any longer than that right now, but at some point when I stretch it out, I'm not going to actually get a triangle anymore because these other 2 sides are going to be too short, right? So if I look at it like this, oh my gosh, this isn't going to want to cooperate. That's okay. When I bring these together like a drawbridge, y'all know what a drawbridge is? Okay, so when I bring it down, the bridge isn't going to match, right? Bring it down like that, you see how it doesn't work? The red ones aren't going to touch, because this bottom segment is too long. So that I have to shorten it so that they would actually work and make a triangle, or lengthen one of these or something like that. Like I could make a triangle like that. But they have to be a specific thing. I can't just use any 3 segments. That should make sense to you, right? If I have like 1, 1, and 15, there's no way it's going to make a triangle because when you close the drawbridge, it isn't going to work. So if the bottom was, if this was 7 and 8, and this comes down, and this is also 7, and this one's also 8, it's not, the drawbridge is going to close all the way to where it actually matches up, and you just have 2 line segments. Does that make sense to you? So they got it, when it closes, those other 2 sides that close, together they have to be bigger than that bottom side, and that's what's happening here. So it says segments of length 7, 4, and 4 can form a triangle, right? All right, so 7, 4, and 4 can form a triangle because these 2, when the drawbridge closed, they actually meet right there. But here, this 3 and this 3, when they keep closing, it's going to be here, and you're going to have a gap there, and it's not going to create a triangle. So that's where the triangle inequality theorem comes in. It's very easy to figure out what the triangle sides have to be able to work and make a triangle. So the triangle inequality theorem says the sum of any 2 side lengths of a triangle is greater than the 3rd side length. Okay, the sum of any 2 of them has to be greater than the 3rd side length. So if you just pick 2, like if I went up here and I looked at this one again, well, 3 plus 7 is 10, and 10 is greater than 3. Sounds good, right? 3 plus 7 is 10, 10 is greater than 3. That works. But is 3 plus 3 greater than 7? No. So if just one of them fails, then they fail, okay? Okay. All right. So let's look at this. So this means that here, the length of AB plus the length of BC has to be greater than the length of AC. And the length of BC plus the length of AC has to be greater than the length of AB. Length of AC plus the length of AB has to be greater than BC. Okay? So you take any 2 sides, all 3 sets have to work. Okay? We okay with that? All right, so let's try this one. This says, tell whether a triangle can have the sides with these given lengths, 3, 7, and 5. So I'm going to do 3 plus 7, and then my 5 right here, with a little question mark. So there's a blank there because I don't know, I want to know how is that related. Well, what's 3 plus 7? 10, and 10 is greater than 5, right? So that's good. Because you have to figure out how they're related. It's 3 plus 7. Is it greater than, equal to, less than? Like what goes there? So then 7 plus 5, got to figure out what goes in this blank here for 3. So what's 7 plus 5? 12. And 12 is greater than 3. So that one works. Then I have to do 3 and 5. So 3 plus 5, we'll blank with the question mark, and 7. 3 plus 5 is 8. 8 is greater than 7. And so, will those 3 side lengths make a triangle? Yes. This is yes. And your evidence, your explanation, is your work right there showing that you tried all 3 sets of sides. Does that make sense to you? Good? All right. Let's do this next one. So 4, 11, and 7. So 4 plus 11, question mark, 7. Then what's 4 plus 11? 15. And 15 is greater than 7, so that's good. 11 plus 7, blank, question mark with 4. What's 11 plus 7? 18. 18 is greater than 4, so that's good. Then 4 plus 7, question mark, 11. What's 4 plus 7? 11. So 11 equals 11. So is that good or bad? That's bad, right? So will these 3 side lengths make a triangle? No, they will not. And there's your evidence right there. Now, although it says, although it says all 3 sets of sides, right? And I really should make you check all 3 sets of sides every single time and make that work and show all 3 sets every single time. I'm going to cut that down a little bit because really, if any of them are going to fail, the first time it's going to fail is when you take the smallest 2 numbers and add them together, right? Not necessarily the first 2 because they're not always in order, but if you just take the smallest 2 and add them together, if they work, the rest of them are going to have to work because the other ones are bigger and you get bigger sums. Does that make sense? So really all you really truly have to check is the 2 smallest ones. And so if you at least do this once instead of all 3 times, just make sure you're really using it. That's why I underlined up here any 2 side lengths. If you're gonna only look at one set, you have to do the smaller 2 added together and see how it relates to the biggest one. Does that make sense to you? That way you're not having to write a ton of stuff that's not even that necessarily important. I mean, it's important, but it's not important that it's important that you know how to test it. It's not important that you always write all of it down. Okay, we good? All right, so now this says, can a triangle have the following side lengths and perimeter? If so, state the length of each side. All right, so I've got a triangle. I need to draw my picture. So here's A, B, and C. So AB is 3x plus 2. BC is x squared. And CA is 2x. Okay. So can I add all 3 of those up and set them equal to 180? No. Why not? Why not? Because they're not angles, right? And the perimeter is not 180. Is it possible that the perimeter could be 180? Yes, but that would be a total coincidence. That has absolutely nothing to do with my angles right now. Okay, so instead, they did give me the perimeter, right? And so I can add them all up and set them equal to the perimeter. So 3x plus 2 plus x squared plus 2x equals 38. First step, 0 work, you plug it all in. Everybody with me? Okay, so now I need to combine my like terms. What kind of equation does it already look like I have? Quadratic. So I need to put my terms in order also. So I'm going to start with the x squareds. So I'll just have x squared because there's only one of them there. And then my x terms, so 3x and 2x gives me what? That's 5x. And then I just have the plus 2 equals 38. Okay, so step 1, I've identified that it's a quadratic. Step 2, what do? Bless you, set it equal to 0. So that's going to give me x squared plus 5x, then what? Minus 36 equals 0. So step 1, identify. Step 2, set it equal to 0. What's step 3? GCF. Is there a GCF? No, but always try, okay? Because if you can factor out a GCF, that will make your life easier. Plus, it's something you need to do anyway. But you can do it last, but you want to do it first because it's going to help, okay? So now you need to factor it. So I'm going to give you a minute while I go check roll, and I want you to factor that. And, all right, so I'm looking for two numbers that multiply to give me the negative 36 and will combine to give me 5. Since this is negative, are the signs of the factors going to be the same or opposite? Opposite. Okay. So my factors of 36 are 1 and 36, 2 and 18, 3 and what? 12, 4 and 9. Does 5 work? No. 6? Yes. And then so now if I keep going, it's just going to be the opposite of all these, so I don't need to list them all out. But so since the signs have to be opposite, I have to think about these two numbers subtracting to give me 5. Which one's the winner? 4 and 9, right? And then which one of those two is negative? The 4, okay? Now, I do not have to do grouping. I'm going to do grouping because I want to show you where some of you are losing it. But then I'm also going to show you why we didn't even need to do that, okay? So if I do grouping, what that means is I'm going to take this and it's going to be x squared. I'm actually going to do plus 9x, and I have a reason for that. I'll show you in a minute. Minus 4x minus 36, okay? Everybody with me? Okay, so now I look for things I can group, right? So I'm going to group these two together and these two together. So here, what can I factor out of the x squared plus 9x? X. So that's going to leave me with, I don't know what I'm writing there. So it's going to leave me with x plus what? 9, okay? Here, if what you have in front of your x is negative, you have to factor the negative out. So when what number, I can't factor out an x over here, but what's the largest number I can factor out? Negative 4. So it's a negative 4, which leaves me with a positive x, and then what? Plus 9, okay? I saw quite a few of you be able to get to this point, and then I don't know what the heck happens after that, but I have left off my equals 0, equals 0. Now what you're doing is looking at what you have. Now I want you to think about what we have. You see here how you have 1, 2, 3 terms right here? And then here I have 1, 2, 3, 4 terms, right? Here I have 1, 2 terms, right? And these two terms have a common binomial factor. I am factoring out the x plus 9, just like I factored out the x here. The GCF between these two big terms right here is x plus 9. You with me? So the x plus 9 comes out, which means that leaves me with x minus 4. And that's where I am. Because a is 1 here, I didn't need to do any of that because I had made my decision right here. And you see how that's x plus 9 and x minus 4? There you go. You get to skip all that. You don't have to do this, but some of you, that's what I'm saying. You do not have to. I would suggest when a is 1 that you don't do that, but some of you are, is what I'm saying. That's what I'm saying. I'm not saying you should. No, some of you are, and that's okay as long as you can do it right, but some of you are getting lost in the factoring this part out. Does that make sense to you? So no, you do not. That's my whole point. That's why I skipped on the first one. You don't have to do this. You can, because for some people it's more important to be consistent, and they do it the same every time, whether a is 1 or not, and that's what they need is the consistency. That's okay. But you you have to do this or some form of something different if a is like a 2 and you can't factor it out. Okay? But yeah, no. You can skip right here. That's my point, is that I suggest that some of you do that because some of you are doing some strange things there. Okay? So now that we've gotten here, my answers then are that I get x plus 9 equals 0 and x minus 4 equals 0. So x equals negative 9 and x equals 4. Okay? Are they guaranteed to both work? No. Okay, so now I'm going to look at what I would plug in up here. And if I plug in the negative 9, well, 2 times negative 9 gives me a what? Negative 18. Can I have a negative side length? No. So I don't like the negative 9, which means hopefully it's 4, or none of this is going to work, right? We did something else wrong. So when I start, I'll look for AB. That's going to be equal to 3 times 4 plus 2. What is that? 14. Okay? And then the length of BC was next, so that's going to be 4 squared. What's that? 16. And then the length of CA is going to be 2 times 4, which is 8. Is there a way for me to check myself? What should all three of these numbers add up to give me? 38. Okay. Do they? Yes. Okay. Now the question didn't ask me for x. It didn't ask me for the side lengths. It didn't ask me for any of that. What it asked me for, it says, can a triangle have the following side lengths and perimeter? If so, state the length of each side. Well, you actually have to state the length of each side, whether it does or not. And then we're going to check it. But remember, instead of checking all 3 sets of sides, we can just take the smallest 2. So if this is going to make a triangle, then 8 plus 14, I want to see how is that related to 16, right? What's 8 plus 14? 22. And how is 22 related to 16? Greater than 16. So what's your answer? Yes. The answer is yes. Oh, great. Now I've dropped my pen and it doesn't work. Shoot. Okay. Hang on, let me go see if I can find another pen. I dropped my pen. Yes. Where did I get what? It's from BC, yeah. All right. I have another pen. Hopefully this one will work. All righty. So the answer then is yes. Okay, so now, it says if 2 sides of a triangle are known, you can find the range of values for the third side. I have no idea why I spaced that out like that. So, I guess I was trying to show you something here. So let's look at this. Let's do, no, you're on the next page. Yeah, you're on the next page. So, X, Y, Z. Okay. So let's say that X is our actual unknown. Right? So if X is our unknown, I'm going to give you links for Y and Z, but we're also going to do it generically with just variables. We'll make this 4 and we'll make this 9. Since we don't know what X is, I can't just check the smallest 2 because I don't know which one's actually the smallest because I don't know the third one. Does that make sense to you? So if this is going to be a triangle, here's what has to happen. That X plus 4 has to be greater than 9. You agree with that? X plus 9 has to be greater than 4. And 9 plus 4 has to be greater than X, right? All 3 of those things has to be true. So what this tells me here then is if I solve for X, if I subtract 4 from both sides, then X has to be greater than 5, right? If I subtract 9 from both sides, X has to be greater than negative 5. And if I just add these together, 13 has to be greater than X. Everybody understand where all that came from? Yes. I subtracted 9 from both sides. Wait, negative 4? I don't have a negative 4. I just randomly gave you those numbers. Okay, so now that I have this, I want to put it all in one inequality. If X has to be greater than negative 5 and greater than 5, doesn't it just have to be greater than 5? Right? And it has to be less than 13. Now, how can I get the numbers 9 or 5 and 13 from 9 and 4? 9. This is 9 plus 4, right? And then 9 minus 4, right? Now, so that I can subtract in any order, y has to be less than x. Oh no, I'm not y. I'm sorry. X has to be less than y plus z. And it has to be greater than the absolute value of y minus z, because those could be anything. It's as easy as that. You're just doing a little inequality. You add them on one side, you subtract on the other. So when I get here and I'm looking for my range of values, x, which is the range, is the absolute value of 7 minus 5 and 7 plus 5 over here. So that means the range of possible values for the side length looks like that. That make sense to you? Subtract them on the left, add them on the right. On the left, if it's negative, you're just taking the absolute value. It's that easy. So here, the possible values for this. On the right-hand side, I add them. What's 8 plus 12? 20. And then what's 12 minus 8? 4. There's your range of possible values. Okay. Everybody good? Any questions? Awesome.